Hello everyone, and I suppose this is the first video. Welcome to the channel. And I suppose with this being the first video, I'll just explain what I'm doing here. So with these videos, I'm going to be teaching you technical design inside of UE5. And what a technical designer does is we kind of make proof of concepts that bridge the gap between game design and programming. So in this channel, we'll be making loads of mechanics that are either done from a unique perspective, meet certain goals, or maybe haven't been thought of before. And with that, any suggestions would be brilliant. But just to start, the first few series I'm going to do, we're just going to get a basic character set up and a project set up. So that really, if you wanted, you could do the first few series and then go off in any which direction, just having a nice foundation. And with what we're going to do first, we're going to be working on this smooth turning system that makes it so that we're not clipping around really messily when we're using the default. And as you can see, before we get into the video, there's a whole scene in here, and so in the description of the video you'll find a link to Google Drive where you can download this project and follow along with me. But just keep in mind that everything I'm using in this video, you can follow along with just any UE5 third person project. So if you want to use this character in these assets, go ahead, but feel no need. And with that, we'll get into the video. Alright, okay, to start, I just want to start off by saying you can download this project folder and follow along with me by clicking on the link in the description and downloading the project. Even though I've added this environment and a character, you're more than free to just follow along in normal third person template. And so just to show you, this is the character movement that you get in the template. It's okay, but as you can see, as we're turning, our character's more sliding about on the floor because all that we're doing is moving a capsule around and just getting animations to correspond appropriately, but it gets something that works but doesn't get the best effect. So today we're going to at least get it so it doesn't feel like we're as much sliding around on the floor. So to start, we want to make it so that the character isn't always rotating towards the camera. And to do that, we go into our character movement and we want to find orientation. Orient rotation to movement, and we want to turn this off. Compile and we'll show you again that now, even though this isn't the best looking effect, we're now no longer rotating to the camera persistently, and gives us basis to start. So first we want to go into our viewport and we want to add an arrow. This will be our target arrow, and this will get the rotation that we always want the character to go to. To do that, we want it to work just like how the character did in the default. So we'll get the tick, and we'll get our camera boom and our target arrow. So now we want to get the rotation of the arrow, the world rotation, and get the target rotation of the camera boom, and then set the world rotation of the arrow. You see, if we right click on this little purple circle, we can split the struct pin to split the rotation variable into 3 float variables of each coordinate of the rotation in the X, Y, and Z. And we're doing this because we only want to get the Z rotation from the camera boom. So that this way, say if we look up or down, the arrow won't look up or down, it'll only follow the camera boom on the Z. And if we see here, first we need to go into our target arrow actually, and as we will see, if we type in hidden in game is ticked. We don't want that ticked. So now we can see that this arrow is always pointing in the direction of the camera, giving us a target rotation. Which we could just take the target rotation of the camera boom, but just for visual and debug purposes, this is a good visual indicator. Right, so moving on. We now want to create another arrow. And this will be our direction arrow. Right, unpairing it. Oh, it's not letting me. There we go. Scale this up in a little bit and we'll make this blue. There we go. And then just change the name, I'll put in direction. And this will be our direction arrow. And we will interact with this direction arrow just like how we were interacting with the camera's rotation at the start, and we want to always rotate the character towards this arrow. So that then we can try and slowly rotate the blue arrow to the red arrow over time, giving us smoother turning. And to do this, we need to get both our arrows and their rotation. And then from here, we want to do an R interp to, just interpolating us from our direction, which is what we're facing, to the target over time. And then just to finish this off, we want to get delta time. Or rather, delta seconds. And just for now, we'll add a random number like 3 into here. Though we will be adding some functionality here soon. Right, and now if we test this, oh, we did it again. And as you can see, now this blue arrow will always follow the red. And now all we need to do is make it so that when we're moving, the character will be rotated towards the blue, and so that whenever we're turning, we slowly rotate towards the red. So first, we want to add a branch here to make sure that we're only trying to turn the player when we're moving. And then if we look over here, we have this axis value, which is the move forward / backwards. So we can actually get that. And then if it's greater than 0, we will be moving. Oh, I think later we'll use something to do it when it's less than 0 as well, because anything less than 0 will be moving backwards. So we could also, even though the backwards movement at the end of this will be a bit broken, but we will solve that in a later video. But if we do it like this, then whenever we're moving, we will be trying to rotate the arrow. And just from here now, all we need to do is rotate the character. So if we get our mesh and go set world rotation, and then we could easily just plug this into here. And then I suspect something's going, yeah, that's fine. So I want to break the rotator and modify that. Make now we need to plug out from here. So we need to break the rotator apart just to deal with that little problem that if we do a minus, maybe it's just subtract. There we go. Yeah, and then if we just take 90 degrees off that and press play. Oh. Maybe it's minus 90. Oh, we didn't plug it in, that's why. Yeah, and now you see over time we should be turning. It's still not perfect though, so what we really need to do is fix this. Well, first off, this was ticked into the wrong place. But yeah, we're going to make this a bit more powerful. And so what we want to do is that depending on the angle between the two arrows, make the interp speed faster or slower. So that if there's a larger angle between the two, we'll spin faster. So from there, we want to get our 2 rotations again, and we'll put it down here and get the delta. Delta kind of works, yeah, like a normalized difference. So we'll take the difference and always make it a positive. Split short pin, and then just to crunch the numbers down a little bit, we need to divide it by 90 and just make sure we're getting an absolute value, which we should be anyway, but just to be safe. And then we can use that to lerp as an alpha for a lerp between, we'll try 1 and 4. Plug that into the inter speed, and that should work for us. Oh, we didn't get the target arrow. Right, and now, yeah, it's a bit slower. As you can see, it's a bit more of a smoother curve. Right, brilliant. It still doesn't look the best. Inside the project folder, there should be animations for turning, which I think I'll tackle in the next video, because right now, with the default UE5, there's some issues with adding animation because of the inbuilt IK system that the default UE5 gives us, which means that any animations that we give, unless we turn off the IK, the feet don't move from the floor, we just slide around. So in the next video, I think we'll try and tackle that and just have a system where whenever we're moving, we're able to turn off the IK. But we do have a temporary solution, which we will tackle now. So if we minimize this, and also if you wanted to follow along, at the end of, in every video, there will be a completed version of what we aim to achieve by the end of the video. If you just want to follow along with that, you just click on this test and it should all be there. I think an easier way of finding it, we go to our mesh and we're trying to access the animation blueprint. Yeah, we just click this browse to asset, or yeah, and then if we click that, then it takes us straight to our animation blueprint. Now, as you can see here, I've already worked in this a little bit, but we'll just walk you through what we did. So first, let's go for our event graph is completely the same. And you want to add this chest twist float. And then I'm sure that this should be exactly the same. Yeah. And then if we go back to our animation graph, you guys won't have this. And so what we're doing here basically is in these two transforms, if you can see here, we're getting spine 3 and we are rotating it by minus 60 degrees and plus 60 degrees. And the reason why we're having to do it in 2 nodes is because we're not able to let the alpha go into the minuses. So from here, if we disconnect this, we press 0, compile shouldn't change, but then when we press 1, we are turning the chest, which means that when we're turning, the chest is turning to our direction or our target before the player's feet are, which is how we actually move, giving us a bit, simulating a turning animation a little bit. And so if you see it, we want to make this chest twist variable, and in both we want to select the float based on if this is greater than 0. So just so that if it goes into the minuses, it means that we're turning the other way. Because right now he's turning left. And then if it's minus, he's turning right. And in this float, that's why we want to times it by -1, because if this is true, this will already be in negatives, and therefore it's the wrong kind of, is a value that won't work well with the float. So we're just inverting the float so that it'll work with this transform modify. Yeah, now if we go back into our third person character, well, this is our test character actually. There we go. Now, yeah, so if we look here, all we want to do is access that chest twist. And to do that, I think we need to get begin play. We actually need to access that animation blueprint. So from begin play, we get our mesh, and then get the mesh's animation instance. Well, I think it's just called anim instance. Yeah. Get the anim instance, and then we want to cast it to the actual animation file, just so that it gets all the same information, and then set it as a variable. We'll change that to motion graph. So now, from this, we can get any variable that lives inside the animation graph, like the chest twist. Oh, we actually want to set it. Plug that into here. Put that into there, and then right now, if we do this, it should work. So there's some issue. Oh, I know. So when we divided it by 90, this basically gave us a alpha value of the twist. We wanted to plug it into there instead. Just make a reroute node here, plug it in, and now it's not perfect, and we will try and solve it so that we can add actual turning animations later, possibly in the next video, where we'll solve 4-way directional movement as well. But now we have something that enables us just to get some better turning from our characters. And I think in the animation graph, maybe if we made this a little bit more extreme, maybe we get some better results. Yeah, it's a bit more exaggerated there, if that's what you want. But right, that was our first episode on character movement. Next time we'll be tackling some of the issues that we created by making this system, like the four-way movement not really being very accurate and trying to add some animations. Right, but if you like the video, please leave a comment, tell me how it did, if you think there's anything you could improve about the system, and we'll see you next time.